Hello everyone, I just wanted to go through some programming examples so that we could get the feel for conditionals. Just kind of follow up on the video. We'll do some of the examples from the video, but we'll also elaborate a little bit on them. So the first example looked like this. We had a variable called Pokemon HP. We set the value to 5. We had another variable called Pokemon name. By the way, the naming system that I'm using here is the snake case naming system, which is standard for Python. I'm going to set this to Tepic. Then we're going to have a simple if statement that's going to check to see, is the Pokemon HP less than 0? If it is, we're going to print Pokemon name has fainted. Okay. And if you don't remember what this format here is, this F string here, or a format string, allows you to insert variables. So you put these curly brackets inside the string itself, in between the quotes, and you can have any expression in Python in between the curly brackets. So in this case, I just have a variable, but you could also compute a math expression or something like that as well. So finally, when we're finished, let's just double check to make sure that the Pokemon HP is the value that we think. So we'll have a print statement at the end that says something like Pokemon HP. Now, instead of just printing that by itself, I'm going to put an equal sign at the end. And let's just see what that does when we run this program. Okay, so at the end, you can see that instead of just printing just the value of Pokemon HP, it prints out Pokemon HP equals and then the value, which is pretty handy, especially when you're debugging your program. All right, so this is a situation where the condition turned out to be false because the Pokemon HP is not less than 0. So let's set it to -2 like we did in the video and execute the program again. We should get 2 lines of output this time. So it says Tepig has fainted, and we can confirm that by looking at the Pokemon HP value. All right, so there we go. So let's try an if-else statement then. So in the video, we had a Pokemon type, which was set to fire, and then we also had a move type. This is in reference to the same type attack benefit in the Pokemon games. If your Pokemon is a fire type and it uses a fire type move, it gets a bonus to its attack. And so what we're going to do here is I'm going to check to make sure that the Pokemon type is equal to the move type. It's just a simple comparison. All of these conditions, by the way, they have to be an expression that evaluates to either true or false. So a less than symbol or a double equal sign, which checks to see if 2 things are equal, those return either true or false. In this case, it's going to return true if Pokemon type is equal to move type, which it is. There's also, by the way, a not equals operator here, which is just the opposite. So in this case, this operator here would return false because Pokemon type is not equals to move type because they're equal. Okay, so let's actually set the move damage. We're going to set the move damage to 30 in this case if it has the same type as the Pokemon, and the else condition is just to set the move damage to an unmodified 20. All right? And just to confirm when we're done, I always like to have a statement at the end of the if statement so that we can see only the code that's indented here is actually a part of the else, and only the code that's indented here is actually a part of the if statement. This code here that's not indented, it's going to execute no matter what. So I'm just going to call this if else, and then we'll put something like move damage in here. I'll put the equal sign there as well. And let's label this one as well, since we're going to have a bunch of output here. So I'll just put if up there. So when we look at the output, at least we'll know where the output is coming from. So let's run this program now. So now we have this third line of code, and it says if else move damage equals 30. And that's because they're both equal to fire. So let's change this. Let's say that our fire type Pokemon tries to use a water type move. Well, now they're not the same type anymore. So this move damage equal 30 line won't execute. It'll execute the move damage 20. So you can see in this case, move damage is indeed equal to 20, just like we'd suspect. Now this is actually a little bit of a complicated way of doing it, really unnecessarily complicated here. These 4 lines of code can easily be reduced. What we could do is set the move damage by default to 20, and then we could just check to see if they are the same type. We could just say if the Pokemon type is equal to the move type, then we could just say, well, set move damage equal to, let's actually set it equal to 1.5 times its original value. So in this case, we'll just do the exact same thing here, except this is the simplified. Let's just put simplified. So now we run this program. Next to simplified, you can see we end up getting the same result. And I can change it back to fire just to make sure that we get the same result. But we've simplified the program. We've reduced 1 line of code. And it depends whether you think this is simpler or not simpler. One of the things that you'll notice here is that because I'm multiplying by a floating point value here, the move damage becomes a floating point. That's actually easy enough to fix if you wanted to do that. So for example, we could say move damage equals move damage times 1.5. That's the equivalent code, just not short form. And then I can convert that to an integer, or I can call something like the round function if I want to. So if I just do int, let's see what that does. See, it does convert it to 30. Just note that when you're converting it to an int, all it does is chop off all the decimal parts. It doesn't round up or round down. It literally just removes all of the fractional part of that number. Okay, so let's now try out the if, elif, else type statement. So we're going to say, let's look at the opponent's type. If the opponent's type is fire, let's say, then we're going to have an if statement that's going to say, well, if the opponent type is fire, let's say I have a Pokemon that's very weak to fire. So in this case, I might set move damage equal to only 10. I only get half the damage because maybe I have a water type Pokemon, let's say. But if that's not the case, I can have an elif condition where I can say, what if opponent type is something else? So in this case, I can check to see if it's a water type. If it's a water type, I don't know, maybe I'm actually strong against that particular type of Pokemon. So I can set that move damage to 30. And then finally, if it's any other type, then I can set the move damage to the normal 20. So this is the case where I'm weak to that opponent. This is the case where I'm strong to that opponent. And this is just the normal case. Okay, so I'm going to actually duplicate this to save myself a little bit of typing here. And I'm going to call this if, elif, else. Okay, let's see what that looks like in the code. So I've set opponent type to fire here, so I would expect move damage to be equal to 10. And it is. Let's set it to water. And execute it again. And it's equal to 30, not surprisingly, because we have an elif condition specifically for water. And let's set it to grass, which should trigger the else condition. When we run this, it should be equal to 20. There we go. And of course, you can have lots more. Let's do one more example to kind of illustrate that. Let's complicate things and say, well, I want to be able to handle if my Pokemon is a different type and the opponent's Pokemon is a different type. So let's have a variable for that. So we'll have a variable for our type, which I'm going to initially set to water. And I'm also going to have opponent type. And I've already declared this variable before, but I'm just going to override the value right now, so it'll make it a little easier for me to change it when we're testing. And then I'm going to have a more complicated if statement that's going to check 2 things. So first I'm going to check to see if our type is water. And then I'm going to use the AND keyword to check if the opponent's type is equal to fire. And this is only going to be true if this right here evaluates to true and this right here evaluates to true. That's the way and works, just like it works in the English language. So both of the two conditions joined together with an and, both of them need to be true in order for the whole condition of this if statement to be true. There's also a keyword called or that you can use, which will evaluate to true if either the left or the right part of the expression evaluates to true. But and needs them both to be true. So in this case, if we have a water type Pokemon and the opponent has a fire type Pokemon, then we should get move damage 30. Right, we should get more damage because water is strong against fire. What if our Pokemon is a water type and the opponent type is also water? Well, in that case, the move damage should be reduced because obviously water type Pokemon are somewhat immune to their own type. And then I could say, well, what if our type is water and the opponent's type is grass? Well, in that case, grass is strong against water, so water moves don't work particularly well on grass types, so that's also going to be another situation where we have move damage 10. All right, let's keep on going. We're going to obviously have way too many conditions to go, but I just want to show you that you can have many conditions, and also your conditions can have more than one thing that you're actually checking in the code. So let's just do one more just to illustrate how this would continue. So what if we were a fire type Pokemon and we were going against, say, a fire type Pokemon? Well, in that case, the move damage would be 10. And so on and so on and so on, right? There's probably lots of other examples. So let's just put it, etc. So in this case, I'm going to put printf, and we'll just call this section Boolean because we introduced the and keyword here, which is a Boolean operation. And Boolean operations, just like the comparison operations that we've been doing, less than, greater than, equals, not equals, those actually return a true or a false value. So you can use them in the same way that we were using the equals and the less than and so on. Okay, so let's put the move damage here. And we'll just have to do a few examples to try this out. So in this case, we've got water and fire, so the move damage should be 30 according to this bit of code right here. So let's see, it looks like it is. What if we have water and water? And move damage is 10, that makes sense. Water and grass, that's going to be the third case here. Well, that's also 10, so maybe I should have chose different values, but I was just trying to be accurate here. And then if we had fire and fire, then we should also get move damage 10. But if we put anything else, because we don't have an if and else statement in this case, if we put something like fire and water, so we have water and fire, but we don't have fire and water, there's no case for that. Presumably I would have put more, but I didn't complete that. So in this case, none of these move damage lines are going to execute. So what we're going to find is move damage is going to have the value that it had from the previous code. So up here, we set move damage equal to 20 up here in this code, and it still has that same value. If any of these conditions are true, they overwrite the value to either 30 or 10. But in this particular case, where I have fire for our type and water for the opponent's type, doesn't update that value. So this is the leftover value from previous time. If you want to just verify this for yourself, what you can do is you can change this variable name here to something like water damage 2, for instance. And then let's see what happens in this case when I run this, because this is a completely separate variable. We're not going to see the leftover value from the previous block of code. So in this case, when we get to this line of code, it says there's no variable called move damage, because only when you actually assign a variable in Python does the variable actually exist, which is why in the animations I tried to show that the variable table actually gets updated when you reach the statement where that variable ends up getting initialized with its first value. Okay. Okay, so that should be enough for today. So in the next set of videos, we're going to be talking about loops.